All right, this will be for dividing polynomials. Just a quick review. Let's say in grammar school, the teacher asks you to divide 342 divided by 5. Okay, the part you're dividing by, that goes out front, and you are dividing that into 342. So you would say 5 into 3 doesn't work. 5 into 35 goes 6 times. 6 times 5 is 30. And then you subtract 34 minus 30 is 4. Bring down the 2. 5 into 42 goes 8 times. 8 times 5 is 40. You subtract once again, and you have a remainder of 2. All right, that remainder of 2 actually goes over the 5, like so. So the answer would be 68 2/5. All right, so we're going to be doing the same thing with polynomials. All right, you want to remember, basically, when you're dividing variables, the same variable with different exponents. For instance, let's say you do x to the 5th divided by x squared. Well, of course, you are just subtracting the exponents going down. Okay, so you keep the x, and the exponent is 5 minus 2, or just x to the 3rd. All right, one more thing I would like to mention is that you want to write the greatest exponents first, okay? So let's say if you're dividing x squared minus 3x to the 3rd plus 5, okay? You would want to write the negative 3x squared, 3x to the 3rd first. And then you would write the positive x squared second. And since there's no x, you would write a 0x and then plus 5. Okay, so when you set up to divide, you want to have the greatest exponents first. You want them in order, counting down by ones. This is x to the 3rd, x squared. This is x to the 1st, and x to the 0. So that's how you're going to be writing or setting up the division. All right, so right here they want us to find the quotient and remainder using long division. Okay, and just for your information, I'm not that big on terminology, but the denominator is generally considered the divisor. All right, and the numerator is generally considered the dividend. All right, I'm not that big on definitions, but just for your information. Okay, so we write the divisor, we write that out front, so we have the x plus 2 out front. And the dividend is this right here, 4x squared plus 3x minus 5. All right. So this is just like grammar school math. Okay, basically we're saying what times x will give us 4x squared. Or another way to look at it, we can say 4x squared divided by x gives us 4x. All right, and now we just distribute to both terms. 4x times x is 4x squared. And 4x times positive 2 is positive 8x. All right, just like grammar school, we subtract this whole thing. I suggest you use parentheses when subtracting. All right, 4x squared minus 4x squared is 0. 3x minus 8x is going to be negative 5x. All right, just like grammar school, you bring down the next term, negative 5. All right, and once again, we are going to say what times x gives us negative 5x. Or you can say negative 5x divided by x is just negative 5. All right, once again, distribute. Negative 5 times x is negative 5x. Negative 5 times positive 2 is negative 10. Subtract this whole thing. Use parentheses. Negative 5x minus negative 5x is 0. Negative 5 minus negative 10, the two negatives make it positive. So negative 5 plus 10 is 5. Nothing left to bring down. So that 5 is your remainder. All right, and if you want to write the answer properly, that 5 goes over the divisor. Okay, so we have a positive 5, so it's going to be plus 5 over x plus 2. All right, so that right there is your final answer. All right, that 5 is divided by x plus 2. I just ran out of room there, so I couldn't write it vertically, but this right here is your answer. All right, again, since we're doing the terminology, I'm not that big on definitions, but the answer, that is actually considered the quotient. All right, so that's it. All right, next example. Example 2. Even if you're dividing by a trinomial or something with 3 terms, it's still the same process. Okay, this one's already set up in order of decreasing exponents, so the larger exponents are first, and it just counts down by 1. Both in the dividend and in the divisor, the exponents just count down by 1. All right, anyhow, we're basically asking what times x squared gives us 3x to the 4th. Or you could say 3x to the 4th divided by x squared. Well, that's just going to be 3x squared. Okay, in case you didn't see it, 3x to the 4th divided by x squared. You keep the 3, and on the x you just do 4 minus 2. All right, and just like before, you distribute 3x squared times x squared is 3x to the 4th. 3x squared times 2x. Do the coefficients and x's separately. 3 times positive 2 is positive 6. X squared times x is x to the 3rd. And finally, 3x squared times negative 3. 3 times negative 3 is negative 9. And x squared, and there's no x here, so it's just x squared. Okay, and just like before, we are subtracting this whole thing right here. So use parentheses. Minus that whole thing. All right, 3x to the 4th minus 3x to the 4th, that's just 0. 5x to the 3rd minus 6x to the 3rd is going to be negative 1x to the 3rd. And negative 4x squared minus negative 9, the two negatives make it positive. So negative 4 plus 9 is positive 5, and we still have x squared. All right, once again, what times x squared gives us negative 1x to the 3rd? Or you can say negative 1x to the 3rd divided by x squared is what? Well, let's see, if there was a 1 here, and we did negative 1 divided by 1, that's going to be negative 1. And if we did x to the 3rd divided by x squared, that's just an x. All right, let's distribute. Negative 1x times x squared would give us negative 1x cubed. Because x times x squared is x cubed. Negative 1x times 2x, we'll do the numbers separate, coefficients separate. Negative 1 times 2 is negative 2. And x times x is x squared. And finally, Negative 1x times negative 3. Negative 1 times negative 3 is positive 3. And we have x here and no x, so it's just an x. All right, I apparently forgot one step, and that was to bring down the next term, the positive 7x. So you want to bring that down. All right, that's why it's good to write them in decreasing order, because I saw the 3x didn't have a term right there. So that's how I realized it. Anyhow, we subtract, once again, just like grammar school. We subtract this whole thing. Negative 1x to the third minus negative 1x to the third, that's 0. 5x squared minus negative 2, the two negatives make it positive, and 5 plus 2 is 7. We have x squared. 7x minus 3x is positive 4x. And this time I won't forget, bring down the next term. So that negative 1 is going to be the next term. All right, last one. We have 7x squared divided by x squared. That's going to be positive 7. And distributing 7 times x squared is 7x squared. Notice every time I get these terms to match. That's the idea. 7 times positive 2x is 14x. And 7 times negative 3 is negative 21. All right, subtract this whole thing. 7x minus 7x, gone. 4x minus 14x is negative 10x. And negative 1 minus negative 21, that two negatives makes it positive. Negative 1 plus 21 is 20. Okay, that right there is your remainder. Okay, and we said the remainder goes over the divisor. So it's going to be plus this in the numerator. So plus negative 10x plus 20. All right, so that's plus negative 10x. Let me erase this. Plus 20. And that remainder is the numerator of the divisor, the thing you're dividing by, x squared plus 2x minus 3. All right, so that's it right there. All right, example 3. Remember the divisor, the thing you're dividing by, goes out front. So that x plus 1 goes out front, and that is divided by this here. Now remember, we said decreasing exponents, but you don't want to skip any. So here, the largest exponent is x to the third. Now we don't have an x squared, so I'm going to write 0x squared, okay? 0 times anything is 0. Plus 0 won't change the value, so I'm allowed to do that. There's no x, so it's also going to be a 0 on the x, and then finally a negative 8. All right, and now it's the same process. X to the third divided by x gives us x squared. All right, I'll actually do this part in a different color. X squared. All right, distributing x squared times x is x to the third. X squared times positive 1 is 1x squared, or just x squared. Subtracting, use parentheses. X to the third minus x to the third is gone. 0x squared minus 1x squared is going to be negative 1x squared. You don't have to write the 1. You need the negative sign, but you don't have to write the 1. Bring down the next term, 0x, and repeat the process. Okay, let's see. Do the numbers and the variables separately. So here we have a 1. Negative 1 divided by 1 is negative 1. X squared divided by x is just x. All right, distributing. Negative 1 times 1x. Well, negative 1 times 1 is negative 1. X times x is x squared. Okay, again, you don't need the ones, but if it helps you, then use it. Negative 1x times positive 1, that's just negative 1x. All right, once again, subtract this right here. Negative 1x squared minus negative 1x squared is gone. The two negatives here make it positive, and 0 plus 1 is 1. We still have the x. And finally, the last term is negative 8. All right. So let's see. 1x divided by 1x, that's just 1, positive 1. Distributing. 1 times 1x is just 1x, or x. And 1 times positive 1 is positive 1. Subtracting. All right, 1x minus 1x is 0. Negative 8 minus 1 is negative 9. Nothing left to bring down, so that is your remainder. So the negative 9 goes over the divisor. Okay, the negative 9 is divided by x plus 1. So there's two ways to write it. Okay, you can write plus negative 9 over x plus 1. That's one way to do it. Or what you can also write, instead of a plus and a minus right here, see it says plus negative 9, you can just write minus 9 over x plus 1. Okay, those are both the same thing. All right, so the final answer is this mess right here. And do we need a negative, do we need a 1 in front of the x? No, we don't. I mean, you don't need that 1 right there. It's really just negative x. So that's basically what you're looking at. All right, example 4. This one is a little bit tricky because you're going to end up with fractions in the quotient. All right, but as always, the part you're dividing by, the 2x minus 1, that goes out front. All right, so we have the 2x minus 1, and that is going to be divided into x squared minus x plus 2. All right, if you want to try it, you hit pause and try this one, but you're going to get fractions in the quotient. All right, let's see. Basically, we're asking what times 2x gives us x squared? Or we have x squared divided by 2x. Let's see, if we did x squared divided by 2x, in front of the x there's a 1. So numbers and letters separately. We have 1/2. And x squared divided by x is just x. So right here is actually going to be 1/2 x. All right, and distributing. Right here, 1/2 times 2 is 1, and x times x gives us x squared. 1/2 x times negative 1 is going to be negative 1/2 x. All right, subtract this whole thing with parentheses. X squared minus x squared is 0. Two negatives right here make it positive. All right, let's see. We have negative 1 plus 1/2. That's going to be negative 1/2. And we still have the x's. Bring down the positive 2. And repeat the process. All right, we have negative 1/2 x divided by 2x. Right, negative 1/2 x divided by 2x. Let's see, the x's are going to cancel. And negative 1/2 divided by 2, we can do keep, change, flip. Okay, keep negative 1/2, change division to multiplication, and flip 2. 2 over 1 becomes 1/2. Right, this is the same as 2 over 1, and you would just flip it. Or what you can also say to yourself, dividing by 2 is the same as times 1/2. All right, so negative 1/2 times 1/2 is going to give us negative 1/4. All right, so that's the next term here. We have a negative 1/4. All right, distributing. Negative 1/4 times 2 is negative 1/2. And we still have the x. Negative 1/4 times negative 1. The two negatives make it positive, so it's just positive 1/4. All right, and once again, we are subtracting this whole thing. Negative 1/2 x minus negative 1/2 x is 0. And I would like to do a common denominator. This is in fourths, and the 2, how many fourths is 2? Well, that is the same as 8/4. All right, so I am going to change the 2 into an 8/4. 8/4 minus 1/4 is 7/4. All right, there is nothing left to bring down, so this is your remainder. So the 7/4 is over 2x minus 1. So it's basically plus 7/4 divided by 2x minus 1. All right, some people might say that is improper the way I wrote that, and the 4 should be in the denominator, but I don't want to do too many different concepts in one problem. All right, so we're going to leave it like that for now. But anyhow, generally speaking, the remainder goes over the divisor. So that's it for this problem. All right, last example for the long division. We have a challenging problem here. The part you're dividing by, as always, the divisor that goes out front. So we have 2/3 x minus 1. And that goes into 4x squared plus 5x minus 6. All right, as always, we're asking what times 2/3 x will give us 4x squared. Or you can say 4x squared divided by 2/3 x. Let's do that off to the side. All right, 4x squared divided by 2/3 x.
At this time, also
Divided by 2/3 x. Okay, x squared divided by x cancels. And we're just left with an x in the numerator. Okay, and keep, change, flip. You want to keep the 4. Change division to multiplication and flip the denominator. 2/3 becomes 3/2. 4 divided by 2 cancels. That's a 2. 2 times 3 is 6. And remember, we still had the x. So
at this time,
so we are looking at 6x. All right, so right here it's 6x. All right, multiply numbers and letters separately, just to make sure. So 6 times 2/3, that's 12 over 3, that's a 4. And x times x is x squared. All right, 6x times negative 1 is negative 6x. Subtract this whole thing with parentheses. 4x squared minus 4x squared is gone. Two negatives right here make it positive, and 5 plus 6 is 11. Bring down your negative 6. And repeat the process. What times 2/3 is 11x? Or you could say 11x divided by 2/3 x. All right, let's see. 11x divided by 2/3 x. X over x cancels. Keep 11. Change division to multiplication and flip the 2/3. So it's 11 times 3/2. That's going to be 33 over 2. All right, so we're going to use that right here. Plus 33 over 2. All right, distributing. 33 times 2 is 66. And 2 times 3 is 6. 66 divided by 6 is 11. And we still have the x right here. And 33/2 times negative 1 is going to be negative 33/2. Okay, finally subtracting. 11 minus 11 is gone. The two negatives here make it positive. And the denominator here is 2. So we need a common one. Negative 6 is the same as negative 12 over 2. Okay, negative 12 plus 33, or 33 minus 12, is going to be 21, and we have a 2 in the denominator. So that right there is the remainder. All right, so the 21/2, positive 21/2, if I have some room here, it's going to be plus 21/2 divided by 2/3 x minus 1. All right, a little sloppy there. All right, but that right there is the final answer. All right, so for synthetic division, there's just a couple rules I want to mention first. The divisor, or the thing you're dividing by, it has to be x plus or minus a constant. Okay, in other words, the coefficient must be 1. If there's any number in front of the x other than 1, then you can't use synthetic division. And the other thing is that every power of x must be included. Okay, remember in the long division, if a power was missing, we inserted a 0 in front of it. For instance, if x squared was missing, we would write 0x squared. Okay, so the same basic concept applies here, as you will see in the example. And just one other thing you'll see in the example. When you're dividing by x minus c, you basically have to change the plus minus sign, okay, on the constant term. All right, so you want to change the plus minus sign, and when you write it, that number, that constant, is going to go out front. Okay, you'll see that in the example, and then we're going to have the coefficients written right here without the variables. All right, like we said, every power of x must be represented, so if it's not there, you use a 0. All right, so here in this first example, we're dividing this polynomial by x minus 2. So we're going to write this like so. And you want to leave enough space here in this bracket for 2 rows. All right, so since it's divided by x minus 2, you want to change the sign on that. and that is going to go out front. So that's going to be a 2. And now under the bracket here, every power of x must be represented. We just write the coefficients. So the first coefficient is 4. The next coefficient, you have to include the sign, that's -5. Right here, if there's no coefficient, it's automatically a 1. So right there, it is +1. And finally, the last one is -8. All right, so we have the 2 out front for the divisor, and we have all the coefficients. So the first step is to bring down the first coefficient, basically the leading coefficient. All right, that's going to be a 4. And now what you do is you multiply. 2 times 4 is 8. And then you just add -5 plus 8 is 3. 2 times 3 is 6. And then you add 1 plus 6 is 7. And then 2 times 7 is 14. -8 plus 14 is 6. All right, so in this section here, all we did was add. And for the 2, we just multiplied, right? We did 2 times 4 and got an 8. And then we did 2 times 3. I'm making a mess here. 2 times 3 and got a 6. And we did 2 times 7 and got a 14. So these are going to be the coefficients for the answer. Okay, and you basically decrease it by 1. So see, this highest power here is x to the 3rd. So this 4 is going to be on an x squared, okay? You decrease the exponent by 1. And then you just count down. The 3 is going to be on an x, so positive 3x. The 7 doesn't have an x, that's just a constant. And the 6 is basically your remainder, so it's remainder 6. All right, if I can make this a little neater, let's just say you take this 2 and you basically distribute or multiply it. Okay, and every time you multiply it, 2 times 4, you get the new answer, 2 times 3, and 2 times 7. All right, so I hope that makes it a little more clear. And right here, you're adding, not subtracting. All right, so this is basically the answer. If you wanted to write the remainder properly, I guess you would just write 4x squared plus 3x plus 7, and the 6 would go over the x minus 2. So that's 6 divided by x minus 2. All right, and right there is your final answer. All right, and if you want to make a little note here, remember we called the numerator, that is the dividend. Right, and we see the highest exponent is 3. So for the answer, we could say greatest exponent is 1 less than the dividend. All right, and that makes sense. Because if you're dividing 4x to the 3rd by an x, the first greatest exponent, the leading coefficient, leading term should have an x squared. All right, so the leading term has an x squared instead of x to the 3rd. All right, next example. Notice here we are dividing by x plus 5. Okay, so we need to change the plus minus sign on that and start with a -5. Okay, and once again with your bracket, Leave enough room for 2 rows. Now, once again, remember, every exponent needs to be represented or included. Notice it jumps from x to the 4th to x squared. So we're going to have to use a 0 x to the 3rd. All right, because adding 0 does nothing, but we need that when we write the coefficients. So as always, make sure they're from greatest to least. Okay, and write the coefficients. We have a 3 on the x to the 4th. We have a 0 on the x to the 3rd. On the x squared, it is clearly -1. Okay, on the x, it's just +2, and on the constant, it's just +9. All right, and then same thing as before. You bring down the first term, that's a 3. And we're going to distribute the -5 to everything on the bottom row. All right, we're basically just multiplying. So -5 times 3 is -15. Okay, and in here, we're basically just adding. So 0 plus -15 is -15. -5 times -15 is +75. -1 plus 75 is 74. All right, let's see. 5 times 70 is 350. And 5 times 4 is 20. So that's 370, but it's negative. 2 plus -370 is -368. And finally, I'll use the calculator. 5 times 368. That is going to be 1,840. All right, and 9 plus 1,840 is going to be 1,849. Okay, I hope I got that correct. I'm going to have to check my answer. But like we said, you distribute the 5, multiply to the bottom row. Every time you do that, you get a new answer each time. All right, and like we said, the degree on the answer, or the quotient, is 1 less than the greatest degree in the divisor. So since this is x to the 4th, this coefficient, the 3, is going to be on an x to the 3rd. Okay, and then you just count down the exponents by 1. This is -15x squared. This is +74x. This is -368 on the constant. And this right here is the remainder. So it's going to be positive 1,849 over x plus 5. And that right there is your answer. All right, so synthetic division is much quicker than the long division. But like we said, you can only use it when you're dividing by x plus or minus some number. If there's a coefficient in front of this x, if there's an exponent on the x, you can't use it. You can't use synthetic division. All right, so the remainder theorem, when dividing a function f of x by x minus c, you can get the remainder by plugging in c in place of x. In other words, f of c. So if you're dividing by x minus c, you plug in c in place of x, f of c. If it were that you were dividing by x plus c, you would plug in negative c. So you would evaluate the function at negative c. So basically, you take the thing you're dividing by and you change the plus minus sign on the constant. You plug that in place of x, and that will give you the remainder. All right, so for this example here, we're going to find the remainder using both synthetic division and the remainder theorem. All right, so we're going to find the remainder using two different methods. All right, so for synthetic division, once again, when you are dividing by x minus 3, you have to change the sign on that 3, so the number out front is going to be a positive 3. All right, in your bracket, you leave enough room for 2 rows. Make sure every exponent is represented and it counts down from the greatest first, 3, 2, 1, 0. All right, let's write the coefficients on the x to the third. The coefficient is 1. X squared, we have a negative 6. On the x, we have a positive 4. And the constant term is a negative 5. All right, as always, bring down the first term. So bring down the 1 and distribute that 3 to the bottom row. All right, 3 times 1 is 3. And right here we're adding. Negative 6 plus 3 is negative 3. 3 times negative 3 is negative 9. Adding 4 plus negative 9 is negative 5. And finally, 3 times negative 5 is negative 15. Negative 5 plus negative 15 is negative 20. That right there is the remainder. Now, we are going to confirm. We're going to confirm that answer. All right, so we said a minute ago in the remainder theorem, when you divide f of x by x minus c, you plug in positive c. So since we have a negative 3 here, we plug in positive 3. All right, so the divisor right here, this is your f of x. And we're plugging in positive 3. All right, so I'm going to take this f of x, and I'm going to plug in 3. So basically, I'm going to evaluate the function at 3, f of 3. Since we're dividing by x minus 3, you plug in positive 3. All right, so that's going to be 3 to the third minus 6 times 3 squared. All right, use parentheses. Plus 4 times 3 minus 5. All right, you can do this on the calculator. Maybe you can do it in your head. Let's see, 27 minus 6 times 9. Okay, I'm going to do this on the calculator. All right, on the calculator, I get negative 20. So that is your remainder. All right, and as you can see, we got the same answer. All right, so this was the remainder theorem, and this was the synthetic division. So we got the same answer. We confirmed it. By the way, if this was x plus 3, then we would plug in negative 3. X equals negative 3. All right, and just like we said for synthetic division, the coefficient on the x, it must be a 1, okay? It can't be anything else other than 1. Otherwise, you can't use the remainder theorem. All right, so in this example, they want us to use synthetic division and the remainder theorem to evaluate f of c. All right, so here they gave us c. But if we took this f of x and we were dividing by x minus c, or x minus 1, we would plug in c equals 1. All right, so let's try it both ways. All right, first I'll use synthetic division. So I want to put the 1 out front. And in the bracket, leave enough room for 2 rows. And make sure you have all the exponents represented and counting down. So x to the third squared, 1, 0. We're good. We have 14, negative 16, positive 10, positive 8. All right. So bring down the first term, that's a 14. And then we multiply, we distribute that 1 to the bottom row. 1 times 14 is 14. And we're adding here, negative 16 plus 14 is negative 2. 1 times negative 2 is negative 2. Adding 10 minus 2 is 8. 1 times 8 is 8. And 8 plus 8 is 16. So your 16 is the remainder. Okay, now let's use the remainder theorem. All right, you want to plug in x equals 1. All right, so let's do that. We have to take the function and plug in x equals 1. So in other words, we're just evaluating the function at x equals 1, which is f of 1. All right, so it's going to be 14 times 1 cubed minus 16 times 1 squared plus 10 times 1 plus 8. All right, this one I can do in my head because 1 cubed, 1 squared, it's always going to be 1. 14 times 1 is 14. 16, negative 16 times 1, positive 10 times 1, and plus 8. So that's going to be negative 2 plus 10 is 8, plus 8 is 16. It checks out. All right, in this section, we're going to completely factor the polynomials. So we are given this polynomial function. We are also given that c equals 1 is a 0. Okay, if c equals 1 is a 0, that means x minus 1 is a factor. So basically, since x minus 1 is a factor, we want to take this whole polynomial and divide it by x minus 1. Okay, now we can certainly do it the long way, but since the coefficient in front of the x is just 1, there's no coefficient here, we can use synthetic division. Okay, remember when you're dividing by x minus 1, you change the plus minus sign and put a positive 1 out front. All right, and then you want to write these coefficients in order. All right, check the exponents. It counts down 3, 2, 1, 0. Greatest exponent is first, so we're in business. The coefficient here is just a 1. Okay, so the coefficient on x to the third is just 1. Right here, the coefficient is negative 4. Right here, the coefficient is negative 7. And the last one is a positive 10. All right, so we bring down the 1. And now basically we are just multiplying. 1 times 1 will give us a 1 here. And then we're going to add these numbers vertically. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. Negative 7 plus negative 3 is negative 10. 1 times negative 10 is negative 10, and 10 minus 10 is 0. That right there is your remainder. Okay, and we knew it was going to be 0 because we already said that x minus 1 is a factor. So it's going to divide evenly with a remainder of 0. So remember that these are now the coefficients on the x's. And the first exponent is 1 less than the leading exponent here. So since this exponent is a 3, the first exponent here is going to be a 2. All right, so that's going to be an x squared. And you can certainly put a 1 in front, but you don't need to. And then you just count down by 1. The next coefficient is -3. And instead of x squared, it's just an x. And the next coefficient is -10. And there's no x on the -10. See, it counts down 2, 1, 0 for the exponents. So as you can see, when we divided by x minus 1, we got this right here. And this we can factor. All right. So this is in the form of ax squared plus bx plus c. We want two numbers. Two numbers that multiply to -10 and add to what number? -3. All right, I think we can do that if we write out the factors for -10. We have 5 times -2. And we have -5 times +2. Which pair adds to -3? Well, that's this right here. All right, so this right here is going to equal x minus 5 times x plus 2. All right, and again, that's what you get when you divide the original by x minus 1. So if you take the original, that's x to the third, I'll do it in a different color. X to the third minus 4x squared minus 7x plus 10 you get this right here, x minus 5 times this right here, x plus 2, times this right here, x minus 1. And that is your final answer in factored form. All right, so just to go over it again, we took the original, if I can erase this mess here, we took the original polynomial and we divided it by x minus 1. All right, when we did that, we got this right here. And then we factored it. So it's going to be this times x minus 1, which is the same as this here times x minus 1. So we had to write out all three factors in order to factor that. All right, example 2, once again, we want to factor this polynomial here, and it's given that c equals 1 is a 0. And that means, once again, that x minus that number, x minus 1, is a factor. Okay, now, since we know x minus 1 is a factor, we're going to take this polynomial and we're going to divide it by x minus 1. Okay, you can use long division, but since there's no coefficient on this x here, the part we're dividing by, we can use synthetic. All right, remember when you're dividing by x minus 1, you have to change the plus minus sign and put a positive 1 out front. All right, let's count down on the coefficients. We don't have an x squared, okay? So this right here is actually the same as x to the third plus 0x squared minus 2x plus 1. All right, now that we have that, we can write our coefficients. In front of the x to the third, it's just a 1. In front of the x squared, it's just a 0. In front of the x, it's a -2. And the one with no x is positive 1. Okay, make sure you account for each exponent and count down from greatest to least. All right, now we're in business. You bring down the 1 and then multiply 1 times the bottom row. All right, 1 times 1 is just 1, and then vertically we are just adding. 0 plus 1 is 1. 1 times 1, again, that's 1, and vertically we're going to add. I'm sorry. This 1 went here. This 1 goes here. Okay, because 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is just negative 1, and 1 minus 1 is 0. That is our remainder. Once again, we knew the remainder would be 0 because we divided by x minus 1, which is a factor, so we knew it would divide evenly. And now, this answer here, these are the coefficients, and the x, the greatest exponent on the x is 1 less than what we started with. So since this is x to the third, this is going to be the coefficient on x squared. All right, you can write 1x squared, but you don't need to. This is 1x, positive 1x, or just x. This is minus 1 without the x, and the remainder is 0. All right, so now we need to factor this here. We want two numbers that multiply to negative 1. Multiply to negative 1 and add to positive 1. Can we do that? Well, let's see. If we write out the factors of negative 1, there's only one answer for that. 1 times negative 1, that's the only thing. If you add these two, it adds to 0. All right? So we can't factor it like that. All right, because these two, when you add them up, they add to 0. It doesn't add to 1, so we can't factor it. We need to use quadratic formula. All right, so what I'm going to do is the quadratic formula. We know this is in the form of ax squared plus bx plus c. All right, so if we use the quadratic formula, that's going to be negative b plus or minus radical b squared minus 4ac all over 2a. All right, the assumption here is that this is set equal to 0, and we're basically just solving for x. All right, so let's see. It's going to be negative b. What's b in this case? Well, it's automatically a 1 here, so b is just 1. And that's plus minus radical b squared, so that's going to be 1 squared, minus 4 times a. Again, there's a 1 here, so the a is just 1. So the a is 1. And c is clearly negative 1. And that whole thing is divided by 2 times a. And we said a was 1, so it's 2 times 1. All right, so we have negative 1 plus minus. Let's see. 1 squared is 1. Negative 4 times 1 times negative 1 is going to be positive 4. So 1 plus 4 under the radical gives us 5. And that's divided by 2 times 1. All right, so it's negative 1 plus or minus radical 5 over 2. So we set this equal to 0. Since these are the zeros, it's going to be x minus each one of those numbers. Okay, so it's going to be x minus negative 1 plus radical 5 over 2 And it's also going to be x minus -1 minus radical 5 over 2. What you want to remember here is that we actually got two answers because of the plus minus. Okay? We basically have -1 plus radical 5 over 2. And the other one is -1 minus radical 5 over 2. All right, if you break up the plus minus, there's two answers. These right here are the zeros. All right, so if you do x minus this and x minus that, you will have the two factors. Okay, so those are the zeros right there. So that is... If you took this part right here, remember we divided. If you took this part right here, that is the equivalent. All right, so rewriting the original, we have x to the third minus 2x plus 1. All right, so the original function, x to the third minus 2x plus 1, that's going to equal the first factor, which was given. C equals 1 is a 0. That means x minus 1 is a factor. So the first factor was x minus 1. All right, then the next factor was... And this here, I see the author did not write it with parentheses, so you can basically write, if you write it neatly enough, you can write x minus, and write this as a fraction, -1 plus radical 5 over 2. And the second one is going to be x minus -1 minus radical 5 over 2. All right, so that mess right there is your final answer in factored form. All right, so to sum it up, this 0 right here, this factor right here was given. We had to divide this here by the x minus 1, and we got these two answers right here.